Hi, my name is Louis Katz. I'm here with Miles.
Howdy.
Altgelt?
Altgelt.
Altgelt,
Yes.
old money. Miles, old money here. And we're going to be looking at his glazes. Here we have a sample of it. And comparing it with glaze recipes and formula in my the program I use called Hyperglaze. So let me move that out of the way. We have here one of the old glaze recipes that I mixed up when I was an undergraduate student. This is Katz 2332 ash. And over here we have the recipe that we use. It's wood ash, Custer feldspar, kaolin, and whiting. And over here we have what's called the Unity Molecular Formula. This is a standard format that ceramists use for looking at glazes. This column, the RO column, are all the ingredients that take the form of RO or R2O. And they mostly exist in the first two columns on the periodic table, the alkali metals and the alkaline earths. And you look down here and this says we have 0.1 mole of potassium and 0.03 moles of soda. Those are pretty small amounts. But 0.8 moles of calcium, and all the glazes that we're looking at today are going to have about that amount of calcium and then various amounts of other things. This over here is the amount of alumina, and alumina controls the running in a glaze. But in these glazes it also controls melting. As the amount of alumina goes down, the glaze is going to melt harder and harder, oddly enough, till the silica gets down low. It's complicated. Over here we have the silica, and all the glazes are going to be relatively low in silica. Most glazes that we use for functional wear have more than 2 moles of silica for every mole in the RO column. So this is Katz 2332 ash, and it's got rivulets. It's a glaze that has rivulets like Miles's glaze. And we're going to look at another glaze here. I've got them all marked so we can just scroll through them. This is Red Art Fake Ash. This is another glaze in the same category. You notice the calcium. The alumina is 0.2, which that actually could be lower. That usually suggests a silica amount that's over 2. But here it only has 1.4 moles of silica. And this is another runny rivulated glaze like Miles's. This one's got more iron than Miles's. It's darker. This is an old glaze test that I just assigned my students years ago. Here we have the calcium again. It's up there, not quite as high. If you add the magnesia in, then we're getting there. And the alumina is even lower, and the silica is even lower. And it says runny fake ash, so that means it gets rivulets like Miles's. Pool's brown, not glossy in the pools. And that not glossy in the pools really means it's not very glass-like. It turns back crystalline, and that's related to this low silica again. It devitrifies, it goes crystalline on you. Oh, here we are. Here's another one. It says fake ash, whitish to green pools. Okay, whitish to green. You notice the iron is lower in here. This is a light colored one. And it's following the same form here. If you look at the ingredients, it's got some feldspar, but if you look at these two, dolomite and whiting, they make up 50% of the glaze. Custer feldspar has some lime in it too, and actually this has a little bit of lime, but it's not that significant. And when you get back and you look at it, you end up with the same thing. Wiser dry ash, similar thing, low amount of silica, twice as amount the iron that the light green glaze had. Here we have wood ash, which is really a source of silica and limestone, whiting, and clay. Yellow ash, same deal. This one's a little bit odd because it has some lithium carbonate in it. It has some rutile in it. Rutile and iron together, especially in high calcium glazes, makes nice yellows. Yellow drip, same deal. It's a runny rivulated glaze. Katz 111. This is not a rivulated glaze. This glaze is a true celadon. It is in here because it's the sort of closest thing to these glazes that's clear and acts like a glass and has no rivulets. If you look here, the silica's